Okay guys, today we're going to be doing a PM FCC check on Midland repeater here, and we're going to go over all the transmit receive tests that you would normally do for a checkout, and I'm also going to check out the duplexer as well. I created a cheat sheet to show the different things that we're going to be measuring here and their ideal measurements put in if it was a absolutely perfect radio. And I'm going to go through how to do the test first, and then when I'm done going through the tests, I'll go back and look at how to do the adjustments on them, and then at the very end I'll put up a series of configuration diagrams so you can get a screenshot of them if you want a reminder of how exactly to do the cables on each one. So we'll just get right into doing the testing, and then we'll go from there, and like I said, we'll finish up with the configurations at the end. So stand by. Okay, test number one, we're testing power out of the transmitter, coming straight from the transmit port into the TR port of the service monitor. On the service monitor, we have it set to monitor mode, narrowband, and we got the correct frequency of 151295. We'll go 40 dB attenuation, and all we're looking for is a power level over here in the display, and we're going to get a measurement real quick and then be done. So I'm going to go ahead and key it up. See, we got 112.20 unkey. Okay, that's a good reading. Now we're going to hit shift 2 on front of the radio and change the power to low, and then check it again. And I got 9 watts, and that's what I tuned it to. So that's a good power there. Okay, now that we're done with that test, for all the other tests after this, we're going to put our transmitter on a dummy load. We're not going to put power into the service monitor anymore. So we'll get that transferred over to a dummy load. And now we can carry on with the rest of the test. Okay, in this test we're going to be measuring the frequency error and the PL deviation of the transmitter. I have the transmitter going into a dummy load, and I have my antenna rubber duck on my monitor port. If we change over to the service monitor, I'm going to come over here and change to 20 dB and change my input to antenna. So now that we'll be able to see the transmitter, and we're going to be looking over at the display here, and we're going to be looking at the frequency error and the deviation when we get to the PL. But first we're going to do frequency error, and it's simple process of keying up the radio, and we see I'm getting currently a frequency error of 44 Hertz, and I unkey. Okay, now the next thing that I'm going to do is go to the PL for a deviation check on it. So let me come down and go mod scope, and we're going to we need to go into our special function screen and put on our 300 Hertz low pass filter to get an accurate reading of the deviation of the PL. Okay, now we'll go ahead and key it up. There's good PL, and I'm getting a deviation of 0.31. So that's a good reading there. And now I can go back to my low pass and change it back to 3 kilohertz for the rest of the test. The next test, we're going to be testing for repeat deviation and max deviation. I've added the cable going from my receiver to my TR port. We're still on a dummy load on our transmitter, and we're receiving off our rubber duck antenna. When we switch over to the service monitor, we're now in duplex mode. We've entered in the frequency for the transmitter out. We've programmed an offset here of 808 to give us the appropriate generate frequency of 159.375. We're using our antenna, and we're using our RFIO out with the strongest signal because we're just dealing with audio, and we want to make sure there's no scratchiness involved. It's all full quieting signals. Now I have down in my audio right now, I have my PL turned off, so the repeater's not repeating. As soon as I turn my PL on, the repeater will start repeating, and we'll get a display up here showing our deviation. And what we're looking for is we're looking for a one-to-one relationship, so that as I change the deviation on my my generator, the transmitter matches it on the output. So let's go ahead and enable the repeater there. I'm going to turn down the volume. And now we're looking at, over on our display here, we're seeing our 1.5 equaling our generate. So let's go back to the generate, and we're going to ramp up and down with it and look for a corresponding equal change on the other side. So as we come down here low, we're seeing a one-to-one, and what you're wanting to look for is the one right above it, the modulation sum. So we can see it tracks just along just fine. Now when we want to look at our maximum deviation, as we crank up the generator, we'll notice on our transmitter up here we reach a peak at about 2.4, right below 2.5, and no matter how much we come up on our receive input, we don't exceed the 2.5 on the output. So we got we got symmetry here below, but we cut off at the upper limit like we're supposed to, even if our input is too much. So we would have a one-to-one relationship with our repeat deviation and a max of 2.5. So let me turn my PL off, and we can move on to the next test. Yep. So that as I change the we're going to be testing the receiver now. So I put the radio in monitor mode, and we're not going to be generating a PL tone, so we don't have to burn up our transmitter while we're doing these tests. I've added a one-to-one isolation transformer coming off my my receive audio, and this is plugged into my sinad meter here. Still generator to receive, TR to receive, and my transmitter's on a dummy load as always. If we switch to the service monitor here, I'm in generate mode. I have the correct frequency. We're going to be testing 12 dB sinad, so I'm running a fixed 1.5K modulation tone, and we're going to just go ahead and increase the signal here until we unsquelch and get a 12 dB reading and get that measurement. So let's go ahead and do that. And I'm adjusting for 12 dB. A little bit there we go. So we're at 0.2 microvolts for our 12 dB sinad, which is passing. It should be 0.3 or less, so that's good to go. Now we're going to look at our frequency error, and all you have to do on that is go up to your frequency warp here, and we're going to adjust it up and see if it gets better or worse. And if it gets better, we'll try and peak it out. So if I come up here, and it definitely sounded like it got a little bit better there. So I'm looking at my 12 dB, looking like I'm peaking out about 13.4, somewhere around there. So I'm going to say at 3764, my receive VCO is going to be off plus 140 hertz, which is not terrible, but there's no warping of that. That's a hardwired circuit, so there's no adjusting of that. And now you can go back down and go the other way and confirm that, yeah, I'm definitely getting worse as I go down. So that was an accurate reading there. So we'll do the plus 100. We'll go plus 140 hertz for our frequency error. Now the next measurement we're going to do is the tight squelch setting. So I'm going to, I've already adjusted my pot in the radio itself to fully maximum, and I'm going to go ahead and adjust the squelch on the front of the radio for maximum as well. Okay, it's set at 15 now, and so we'll go back to our signal level here, and we're going to crank it up until we open it up, and we'll see what our max tight squelch setting is. So let's get up here and sneak up on it. There it is. 0.31 microvolts, about minus 117 dBm. So that's our max tight squelch, and the like I said, that's with the pot and the physical pot and the electronic pot on the front fully engaged. So that's as much as you can get. So let me ramp it down here. So that concludes that test. Okay, on our next test, we're going to be testing the duplexer, and basically we're going to be measuring the signal when we inject a signal here that's on frequency, how much loss we get going through this side of the duplexer, and we're looking at something, we want to have it under 2 dB so that the correct signal coming through here gets to pass through with minimum attenuation. And then we're going to put in the reject frequency, and confirm that it blocks just about all of it out from getting through that way. So we're looking at a pass and a reject scenario here. To start off with, what we want to do is go over to our service monitor here, and we're going to jumper directly from our output to our input, and this is going to give us a reference level, and I'll show you what we're going to do with that. So let me come into here to the service monitor. Now, right now I'm in duplex generate with no offset, and I'm generating out a minus 30, and I'm receiving back a minus 32.1 there. So I got a either in my service monitor, I'm sure it's not the cable because it's so short, but in the calibration of my service monitor, either the output or the input, I got 2 dB difference on the service monitor itself. So I got to keep that in mind when I go to look at the values, to go ahead and subtract 2 dB from it to get it back to where it was supposed to be. So let me go ahead and stick it back now, its original configuration here. But you see the idea that what I'm doing, and I'm going to do the same thing when we move down to the other one, just a back and forth. And I can see right now, if you're wondering, does this part of the duplexer need to be terminated or not? I've tried it both with and without, and it's really immune to it. It doesn't seem to notice it at all. In general, though, if you are working on any kind of RF devices that should be terminated and they're not, go ahead and terminate them so it balances everything out 50 ohms. But let's go ahead and switch over to the service monitor display here, and now we'll notice as I'm going through the cans, my input level is down to, now it's minus 33.4. So take away the 2, I've essentially lost about 1.2 dB going through, and that's very typical and that's very acceptable. And you'll see later on when we do the transmit test, basically if you put 100 watts into it, you'll get about 75 out. So that's not a bad trade-off for what it's doing for you. Now let's go ahead and flip frequencies to the other side and confirm that we get complete rejection on that. So let me change the frequency there, and now we've come back, and you'll notice the signal is completely gone. And if I come down, I can actually increase my signal level here all the way to 0, and you still can't see it at all. It's probably got 70, 80 plus dB attenuation. They're really sharp notches. So we're completely good to go with that. Now all we got to do is switch cables and switch sides and test the other side. So let me come off of this. Turn it up here. But like I said before, it's really not necessary, but let's just make it official. Okay. Now we're hooked up to the other side of the duplexer. Now we're testing these cans to see how much they attenuate the one signal and let the other signal pass through. So if we come over to our monitor and look, we'll see that we're at 33.1. So we're only losing 1 dB going this way, which is great. And we'll go ahead and flip the frequencies again, and now we should see a complete drop away and once again go down and turn my level all the way up to 0, and you still can't see anything. So we're completely notched there, and that's a good duplexer in both directions. Okay, for the next test, we're going to be testing for sight desense, and which is basically how much RF noise is present at your site that impedes your receiver from receiving a signal, and any transmitter out in the field trying to talk to that receiver has to overcome that initial interference in order to get into the receiver. So this is going to be a measurement of that noise that's present. We first do a 12 dB sinad test using an ISO-T input coming from our generate port, and we're going to first get a level measurement using a dummy load for the antenna, which is the representation of the perfectly quiet radio site, and then we're going to switch to an actual outside antenna and measure the difference between the two, and that'll give us our sight desense. And you take whatever that measurement is and add it to your basic tested receive level and add it to it, and that will be your effective sensitivity. So let's switch over to the monitor, and we're going to once again, we're in sinad reading mode. I'm going to generate the signal until we get 12 dB sinad, and then switch over to the antenna. So let me crank up here and adjust for 12 dB, somewhere around there. It doesn't; these aren't super accurate measurements, but anyway, we got -72 there. So let me change now from the dummy load to an antenna, and then we'll see the difference. And you can hear it a little bit scratchier there, but not much. I'm on my outside antenna, and it's pretty much out here in the boonies, so I'm not getting hardly any noise coming in at all, not even enough to make a change here on my level. So I'm going to call that a 0 for my sight desense. So let me go ahead and we can stop that test. Okay, for our final two tests here, we've now hooked the transmitter up to the duplexer, and we've inserted a watt meter in line with our antenna output here, and we're going to go through and we're going to do the 12 dB sinad again for coming in here on our ISO-T, and then we're just going to key our transmitter and confirm that we have no internal interference, and also if there was when we transmitted, as power went out into the antenna in the world, if there was something out there that was causing a mix and sending a signal back in that's on our receiver, we would see it doing this test. So this is going to be our local desense, and like I said, ideally you shouldn't see any change in this, because your duplexer is completely protecting your receiver from your transmitter, and then hopefully there's nothing out there in the world that's giving you troubles as well. So let's go back over to our service monitor, crank up the level again until we get our 12 dB sinad back. Somewhere around there. And now we're going to go ahead and key up our transmitter. And you see we get a little bit of something there. So that's something that's coming back. Now, if we wanted to, we could swap over. I'm going to first just check my watt meter and make sure I got nothing reflected, and I'm good to go there. Now I'm going to go ahead and swap over to a dummy load and see if we have any change there. And we're still seeing a little bit of difference there, so let's key it up and crank up our level. So that was about 2 dB. So we're definitely getting into ourselves a little bit, although I'm fairly positive it's not the duplexer, it will be the internal dynamics of the radio itself. But you could just add that little bit of change to your effective sensitivity in the end, but not really an issue. So last but not least on this whole deal, we're going to do the watt meter check to make sure we have the right amount of power out. And like I said, for 100 watts out, I'm expecting to see 75 on the output of the duplexer. Plus we have cable losses and whatnot, so, but just somewhere in that random area. So I key it up and I'm seeing right at about 80 watts and low here, and almost no reflected at all. Barely makes my needle move. So that concludes all the basic tests that you would need to do on the repeater. The very final test after you put all the cables back into place is to do a radio check with your portable with dispatch. Make sure you have your antenna disconnected from your portable, and everything should be tuned to even with no antenna on. So this concludes your test procedures. Now I will go back in and look at the adjustments needed for each individual test. Okay, I want to go over some of the adjustment spots in the radio and how to get into the internal front panel menu. To start off with, wanted to look at the power. This is your high power adjustment. There's a pot inside there, and this is your low power adjustment. It's about an inch or two inside there, so you kind of need a little bit of a longer tool, but it's just a standard pot, and it's fairly easy to adjust. It's a bigger pot compared to the other ones. So that's the power out. Now let's take a look at the frequency error. If I lift up the radio here, and we have the transmit VCO over here, and we have the receive VCO over here. And on the transmit VCO, there's 3 little pots here, and the one for the frequency warp is the one in the corner that's closest to the red capacitor here. That's your FVR203. So it's a super tiny little adjustment. You really need to get a micro flathead like I have here to kind of adjust it, and they're very loose, so there's almost no tension when you turn them. They turn very easy. They're only single turn pots. So that's your frequency warp. Now while we're inside the radio, over here on the receive VCO, up here in the corner is your FDR001. This is your tight squelch control. So that's where you'll adjust that. Now, as far as the getting into the front panel mode, what you need to do is you need to short this test point here. It's called TP2. And it's just a little knob of metal that sticks out. So all you gotta do is put a little clip on like that, and then clip on to the to any ground, and then power the radio up. And once it's powered up, it'll go into that internal menu. So let me go ahead and fire it up here and let you have a look and see what it looks like. I'll turn the radio on, and you see it comes up in this adjust mode. So I'm going to set this back down here real quick, take my test jumper off and lay it down flat so you can see the screen properly. Back up here. There we go. Okay, so this is our test menu here, and this is where I come in to do the adjustment for the PL deviation and for the other. Let me while I'm thinking about it, let me go ahead and pull up the radio so you can see where I'm talking about. We'll go next, and we'll go main. Oh, it doesn't matter. There we go. Add that up. Okay. Exit and miscellaneous. Okay. All right. So, in order to adjust the PL and to keep the radio from over deviating, it was kind of a fight back and forth because the PL is controlled by the voice deviation pot, and also all the physical pots on the transmitter there for the PL tones, they're all disabled. They don't do anything because it's all electronic. So to get the correct balance on the radio, what I found is that I had to set the CTCSS to max, and then adjust the radio overall deviation so that the PL is set at 300 hertz. And it just by good coincidence or luck, that happens to also tap out the maximum deviation at just the right point at 2.5. So if I'm over here, and by the way, when you're in this menu, you can go to low power mode with the shift 2. So when you're doing your test, but if I come here, here's my repeat deviation, and here's my analog deviation. This is the one that I adjust. You go A and B for up and down. I adjusted this for 300 hertz PL deviation, and then I came back to the repeat deviation to get it correct in its one-to-one relationship. So those are the two menus that you'll need to get into if you need to adjust that. Once you're done in that menu, all you got to do is turn the radio off and turn it back on again, and it'll go back into its normal mode. So that's that's one thing that you can do to do the adjustments. Now let me go over and look at the cavities, and so you can see what's going on with that. So here's a typical, this is a duplexer that we have. It's a pass reject. So it's got a can that it does two things. It's allowing a band of frequencies to go through, and it's also rejecting a specific one frequency that it really doesn't like to notch out. So the tuning rod here gives you your pass, and your little notch adjustment under the screw here gives the reject. This is a telewave duplexer, and they have an entire instruction pamphlet put together if you ever want to get into how to adjust these, and also to set the insertion loss. They're kind of each duplexer is unique in that you need to really follow the instructions of the manufacturer and not just assume every duplexer is the same, because there are some differences between them. So keep that in mind. Let's see here. And I think that's about it as far as any of the other adjustments are concerned. If you have to get in depth in any one of the items, there's further documentation and testing that you can do to get into each one of the individual parameters. But this is pretty much all you need for your general PM FCC check. All right, here are the final drawings and checkoff sheets to look at if you wanted to do a screenshot. So I'll just go through them for a couple seconds here. Okay, that'll do it. I hope that helps out. We'll talk to you soon.